Good morning to all. Myself S. Shafaz. I am from Electrical and Electronics Department in Srinivas Ramanujan Institute of Technology at Anantapur. Today we are discussing about short transmission lines, phasor diagram and its performances. In Introduction to short transmission lines. This presentation covers the fundamentals of short transmission lines and their performance analysis. Short transmission lines are typically less than 80 kilometers in length and are used for power transmissions. Understanding their performance phasor diagram and performance helps in efficient power system operations. Definition of short transmission lines. A short transmission line is characterized by having a relatively small line reactance compared to its resistance. The line parameters are such that the reactive component can often be neglected in calculations. These lines are usually less than 80 km long, simplifying their analysis. Basic parameters of short transmission lines. Resistance or inductive resistance X and shunt capacitance are the primary parameters. For short lines, the shunt capacitance is negligible and the line can be modeled as a series impedance. The sending and receiving end voltages and currents are key variables in analysis. Voltage regulation and efficiency. Voltage regulation measures the change in voltage magnitude at the receiving end. When load varies, efficient inductance, how effectively the line transmits power with minimal losses. Both parameters depend on the line's impedance and the load conditions. Phasor diagram of short transmission lines. The phasor diagram visually represents the relationship between voltages and current in the line. It typically shows the sending end voltage, receiving end voltage and line current. The diagram helps in understanding the phase differences and voltage drops across the line. Construction of phasor diagram. The receiving end voltage is usually taken at the reference diagram. The sending end voltage is represented as voltage regulation plus the voltage drop across the line impedance. The line current L is drawn at the angle at an angle to the to represent the phase difference caused by the impedance. Voltage drop in short transmission lines. The voltage is proportional to the line impedance and the load current. For short lines, the voltage drop is predominantly resistive and reactive components are small. The drop causes a difference between the sending and receiving end voltages. Performance analysis of short transmission line. The performance is evaluated using parameters like voltage regulation, efficiency and stability. Voltage regulation is calculated as the percentage difference between no load and full load voltages. Efficiency considers the power losses mainly due to resistance in the line. Voltage regulation calculations. Voltage regulation equal to voltage source at no load minus voltage reactance at full load divided by voltage regulation at full load into 100. It indicates how well the line maintains voltage levels under load variations. A lower value signifies better voltage regulation performance. Power losses in short transmission lines. Power losses are primarily due to the resistive component of the line impedance. Losses can be estimated as I square R, where I is the current, I is the line current and R is the resistance. Minimizing losses enhance the efficiency and economic operation of the transmission system. Advantages of short transmission lines. They have simpler analysis due to negligible shunt capacitance and small reactance. Cost and construction are relatively less compared to longer lines. They are suitable for local power distribution where short distances are involved. Limitations of short transmission lines. Voltage regulation may be poor under heavy load conditions. They are not suitable for long distance transmissions due to increased voltage drops. Power transmission's capacity is limited by the line impedance and stability considerations. Summary of key concepts. Short transmission lines are characterized by low impedance and minimal shunt capacitance. The phasor diagram illustrates voltage drops and phasor relationship crucial for analysis. Performance metrics like voltage regulation and efficiency help in assessing line operations. Conclusion and reference. Understanding the phasor diagram and performance analysis is essential for effective transmission line design. Proper analysis ensure reliable power delivery and minimizes losses. For further reading, consult and standard power system textbooks and technical papers on transmission line theory. Thank you for giving this great opportunity.